By way of introduction, my name is Gordon Patrick. I head up the server team within the compute business unit at Micron. I'm based in Boise, Idaho, despite the accent, but I am relatively local to this area. So today, we just wanted to run through how we view the persistent memory market. So just taking a short recap on what persistent memory is, looking at some of the key areas in the market that we believe can be developed, but also looking to the future in terms of what key focuses both the hardware and software developers should be looking at when it comes to designing for persistence. So Arthur had already gave a pretty detailed review on NVDIMM this morning, so hopefully this will be somewhat complementary to that, and I hope I don't steal too much of his thunder, but let's just say he stole some of mine, so we didn't collude on the slides. That's for sure. So why persistent memory? So what is persistent memory from our perspective? It's essentially, we look at the definition, it's basically storage technology, so non-volatile data that performs or has characteristics that are suitable for a load store programming model. That's persistent memory. So we don't consider block I/O as persistent memory. It might have persistent features, but just to make that distinction, so that's why we talk about it. Why persistent memory? What's the need? What problems is it solving? Well, it's actually solving a number of problems, some forced on us and some that are proactive. It's, as Abe mentioned yesterday in his keynote speech, I'm loath to use the phrase perfect storm, but there's certainly a convergence of vested interests in terms of potential market development here. So there's some fundamental issues we're having to deal with regards physics, first of all, and then we have to look at the economic potential of what persistent memory brings, and also look at market demand. So there's just a massive demand for the features that persistent memory allows with regard to large-scale analytics and real-time processing. But with regards to physics, initially, basically, DRAM scaling is slowing down, and that brings issues with regard to latency and energy consumption in the DRAM technology itself. So there's been the continuous search for DRAM replacement, which is not an easy proposition given the massive scale that the DRAM market operates. But there's some new entrants into that memory space. I'll touch on 3D Crosspoint a little bit further on in the presentation. But the barriers to entry to replace DRAM are massive. But the market demand and the economics driven by the need to improve system-level architecture viability will make that happen. So this is our version of the memory storage hierarchy. As I mentioned, Arthur had a similar slide earlier, but this is ours. This is how we take a look at primarily obviously on a hardware platform basis, we look at the landscape from a cost, or in this case, an ASP per bit versus the landscape, versus the latency landscape. So we split it into two sections, memory I/O and memory control and I/O control. Again, today we're more focused on the persistent memory space over to the left. You can see that what we've done here is taken a a further segmentation within the load store section, and looked at what we call the performance optimized persistent memory, which is essentially where we are today, or where we're starting to grow market today. And this emerging area, which we call cost-optimized persistent memory. And I'll touch on what those definitions mean in a second. But essentially, performance-optimized persistence is being driven, from our perspective, by NVDIMM N-type. So we acknowledge the F-type is in the market. For purposes of this discussion, we're primarily looking at the N-type. And NVDIMM N gives you DRAM speed persistence, but it's basically providing low-capacity DRAM to allow you to develop persistent solutions and giving you the backup of the flash in case of a failover. Okay, so that's where NVDIMM N is driving solutions today. As we move over the next few years, emerging technologies like 3D Crosspoint should be able to provide a better cost position with a technology that's near DRAM-like in terms of its performance capabilities, with regard to latency in this example, but is non-volatile, so it's truly non-volatile. And there's still a gap here, and there's still an opportunity here for any other emerging memory to come to market that could potentially have even better performance, but with a similarly competitive cost profile. So that's how we take a look at the hierarchy today. And basically, there's no question that persistent memory is a new memory category in this hierarchy. So this is just a cartoon version of to make a point. Cartoon version, if we say, of a routine, just to really to emphasize what do we talk about when we talk about persistent memory and performance optimization and why it's so important. Well, it's hard to convey, certainly in slideware, the improvements you're actually achieving through committing persistent media onto the load. Oh, I apologize. Onto the load store bus, as opposed to having to commit any persistent variables into the I/O stack. So if these blue, yellow, and green operators are just indicating a standard persistent variable, a write operation that would have to be committed into various media, you can see the vast difference in terms of latency. So with regard to I/O stack, we're looking at, quote, 85,000 nanoseconds, all the way down to actual DRAM speed, which is, we're quoting at 40 nanoseconds. So it's difficult to get that related to real-world example, but for fun, the nearest we've attributed it to is saying that basically this is the difference from, if you're making a sandwich, it takes you so many seconds to go to the refrigerator and grab the tomato, and it takes 46 days to go grow the tomato. That puts it in one perspective. There might be many others. By the way, I don't know if Jason's here from 451 Research. No, okay. I thought his IoT smart refrigerator routine yesterday was amazing, so I was going to congratulate him. So anyway, that's just to emphasize why we're all here. This is why we're all here. Okay, so with that technology benefit, is there a market for this technology? Well, we know there is. We're highlighting here, this is very non-exhaustive in terms of some of the key application areas that could benefit from persistent memory, from the database space, analytics, to scale-out storage. And we're also highlighting here some of the core persistent variables that would be a key improvement in these application spaces with regard to fast persistent writes, write-back caching, and metadata. It's worth noting that when we look at the market over the next 5 years, and this is relatively conservative, but we think at least 20% of all server systems will have some sort of persistent memory. So just to give you an idea of where we see the market growing, we don't think this is niche in any regard. And who knows after 2020 where that market's going to go. Okay, so kind of established persistent memory. It's got value. There is a market. We just want to take a step back and say, okay, how do we see the implementation of persistent memory over the next few years? And we kind of boiled it down to a pretty simple notion, a pretty straightforward two-step notion, phase one, phase two, right? This is important for pretty much the key reason this is important for this audience is to give developers a sense of within what frame of reference will I be able to develop solutions over the next few years? Okay, what's the major macro constraints or opportunities within which I will have to work? From our perspective, and I talk specifically in this instance from a hardware perspective, and I should emphasize, and I should have at the beginning, that's primarily my background. So I'm heading up the server team in Micron from a hardware perspective, not a software perspective, so bear with me on that regard. But right now, we're classifying phase one as NVDIMM. There will be NVDIMM opportunity in here, but we're essentially looking at that market as phase one. So that's happening today, and it's being innovated on, it's being developed. We see the emergence of phase two happening or starting to grow in the 2018 timeframe. So phase two is an amalgam of emerging memory, next-gen memory technology, but also includes the concept of NVDIMM P or -P or P-type. And this is where there will be access, or direct system access will be available to the flash as well as the DRAM. Now that significantly changes the developing or the developer mindset with regard to the ability to utilize that capacity available on the DIMM. Right, so this DRAM plus NAND next step in NVDIMM, it's already in motion with regards to the usual standard bodies and discussions with the enablers. But we are looking at where we stand with the standard I/O in compute. That there's some big rocks that need to be pushed to make sure that this goes through. Also in phase two, as I said earlier, there is the true emerging memory technologies that will offer high capacity and non-volatility. So just a simple notion, but it was really just to demarcate where we stand today and how people should be thinking about the next stage of development in this space in the future. So this slide is really just it's actually it's a long way round at pointing to one specific area for application developers, and that is in this space right here, what we're calling a PML or the PMM library space, and I'll come back to that in a sec. But essentially, with the ongoing progress being made in terms of universal drivers in the Linux and Windows space, we're seeing, thankfully, a move away from the very application-specific point solutions, inflexible APIs and drivers that have been the norm in NVDIMM over the early years. But now with the advent of Linux, in this case, we use Linux as the example, we're seeing a lot of flexibility emerging. We're seeing a lot of innovation happening already. Oh, apologize again. Especially in the emerging in the file system space with regards to direct access mode. There will be, I don't know if any of you will be able to make HP Discover, which is in early June, I think in June 8th and 9th. But they will be showing some pretty exciting updates in terms of benchmarking and case studies that they've been running, specifically using the DAX extensions in direct access mode with regard to tail of the log casework. So and that's just one example, but there's many others. But what we're actually seeing here is over the next few years, we'll start to see innovation in this space. And then with the advent of -P, for example, we should see a widening of the multiple use case for this Linux driver environment as people take true advantage of the capacity. But eventually, and this is coming to the point, the real holy grail from a performance perspective for application developers will eventually drift back again to a maturing PMM library space, really innovating on that true direct direct access from the application to the media. And after that, incorporating the memory management into the OS. So this was really to give just a sense or put a stake in the ground of where we stand today, where we think that development can go with regard to the multiple mode functionality in the driver. But ultimately, we would be driving partners to get to the key performance functionality in the PMM libraries. Okay, this is just a slide just to put some substance behind the previous slideware and some of the things I'm saying. This is block mode driven, so we're not even talking about direct access mode benchmarking in this instance, but both HP and with and one of the key sponsors today, Plexus Store, and there's multiple benchmarking out there to validate the value proposition for persistent memory, either in incremental block mode or ideally in direct access mode. Okay, so why persistent memory? We've developed a market. It looks good. We think we know where we're going. What's the key features that we have to think about over the next few years, given what we've just been looking at? Well, there's this phase 1 and 2 concept back again. But this time we'll talk a little bit more about phase 2. So whilst performance is certainly the holy grail in many, many instances, there will be overall TCO constraints and performance and workload optimization requirements that need designers and need the developers to make key decisions between performance and cost. That's both at the system level and at the device level. So even with the advent of a new class of memory, and whether it's storage class memory or I believe the new politically correct method is to call it server class memory, but still require, from a stack perspective, the need to to optimize the memory storage tier around the economics of the applications it's supporting. So, and that's really making that TCO and that value-based decision around performance optimized and cost optimized decision making. The good thing is that that wasn't really an option before. The indicators are that over the next few years, the market should be afforded the luxury to make some of those key decisions. So in summary, and just including that stack visual for reference, basically the performance optimized persistent memory solutions, it's available today. And also the persistent memory itself is firmly established as a new complementary category, okay? So we don't, you can make corner cases with regard to is with a 3D Crosspoint type solution or some other solution, kill NVDIMM. You can make corner cases, but we're not envisioning that at the moment. We see persistent memory with regard to as manifested in NVDIMM as a true complementary solution. But the next phase of development will be based around the emerging memory controller design, which still offers that secret sauce from an IP perspective, and importantly, the standardization around protocols to get to what we refer to as full system persistence. That's the removal of any volatility, the removal of supercaps, the removal of the need to access or use battery cells, UPSs, etc. And again, just leaving you with that thought, I mentioned earlier that when it comes to absolutely maximizing performance, and that's ultimately where this will head as costs stabilize over the next few years, developers want to take a strong look at the PMEM libraries as the reference for application development. So with that, I will say thank you. I think we had planned some Q&A. So absolutely open for some questions. I'm getting the nod. So if you want to shout the question, I'll repeat it to the audience.
Can you share some thoughts about density and capacity?
Yes. Okay. The question is, talk about density and capacity. So just to give you some ranges, NVDIMM, which is what we talk about, is available today. We don't see that expanding or going more than 32 gigabyte in the near future. Okay? So for the DRAM, yeah. Per DIMM. Yeah, sorry. If I talk in density, it's always in per unit of per DIMM unit. So the early capacities or densities available are 8 gigabyte, but we see that will migrate to 16 and 32 gigabyte over the next 6 to 18 months. The next generation non-volatile solutions will, by definition, have far higher capacity. Once NVDIMM will allow you into the 256 gigabyte range. 3D Crosspoint type solutions could be even higher. So this is why we talk about the trade-off between a performance and, because remember, based on its low capacity, but it's DRAM, you're getting DRAM speed in persistent in format at up to 32 gigabyte. That can still allow you to do some reasonably, I mean, you're essentially using the DIMM as a hardware accelerator in that case. Yes?
NVDIMM, is there
Yes. If I heard the question correctly, is there direct access to the NAND?
Or to the direct access?
Sorry, I can't hear the question.
And you say that there's direct access to the DRAM, but not to the flash.
We're going to walk and talk, sorry. Yes?
In the N version of the NVDIMM, there's direct access to the DRAM, but not to the flash.
That's correct.
But in the P version, is there direct access to the flash or the Crosspoint?
Okay, so question is there direct access to the flash in the P-type version? The answer is yes. That's what gives you the access to the higher capacity. So there's direct system access in block mode. It's block addressability to the flash. In the N-type, the NAND's only used as a backup when the system fails.
Is there any byte direct access in the P mode?
No, there isn't byte address. It's not byte addressable access to the NAND. It's just direct system access to use the NAND when the system's in operation.
Is there a movement to get a Crosspoint DIMM with byte addressability?
Crosspoint's the byte addressable. So NBDIMM, which is based on a variation of DRAM and NAND, you can't get full byte addressability, but with Crosspoint, as an example, you would get it would be completely byte addressable.
So NVDIMM T with Crosspoint would be byte addressable direct access to the Crosspoint memory.
So it depends which media you use for dash P.
If I'm using Crosspoint.
If you're using Crosspoint, it's byte addressable, yeah. Does that answer the question?
It does. Two previous slides, can you go back to those?
Sure, no problem. This?
Yeah, that's Breakout. Is phase one, in essence, Crosspoint, or is that technology?
Phase one?
Yeah.
Phase one is pretty much DRAM and NAND.
Okay. All right. And phase two is what?
Phase two, as I mentioned, is basically NVDIMM-P, which could be DRAM and NAND, but also it could be a completely separate new memory technology, like 3D Crosspoint. But there's a whole ecosystem enabling requirement to make that happen.
Yeah.
So the ecosystem's already in place here, or starting to go in place, that allow this market to grow. The ecosystem needed for this hasn't happened yet. So the technology's starting to become available, but there's a whole standardization, there's a whole inertia in that ecosystem that needs to be addressed to make phase two happen.
So,
Yeah.
So I know the DRAM price decreased 32 per year. So what's your NVDIMM price trend?
I'm glad you asked that question. One of the biggest mistakes that the market allowed to happen was to allow an NBDIMM be called an NBDIMM, because then everyone associates it with the price of commodity DRAM, and it's got nothing to do with the price of commodity DRAM. Okay? So we don't attach any cost per bit, premium, uplift, whatever, between DRAM, as you can buy in the market today, at pretty aggressive prices, and the value proposition that these solutions can bring. So NBDIMM should have been called something else, and it would have stopped people making any connection to the price of DRAM.
So can I ask another question?
Please go ahead.
So I know like
LES, the local energy storage to
Yeah.
the server. So they use commodity DRAM, and so they can get the same performance and same capacity as NVDIMM.
Yeah.
So, you know, the DRAM is commodity, so they can get a lower cost. So
Yeah.
what's your, I mean, the several questions is that since you have some endurance issues, so, and the program have to write some special, take some concerns on the program. So what's your thinking on that? Like people now you can use commodity DRAM to build a non-order memory compared with your Crosspoint. The first question.
Yeah.
Second question is that what's your Crosspoint like memory technology? Is it a PCM or something else? And
Well, let me stop you there. You're two questions and counting, so I'm going to. I'm in the memory business, but I have to keep. Yeah. So let me address the second question first, which was what type of technology is 3D Crosspoint. I can't talk about that. Okay, so that's an easy one. Your first question about using commodity DRAM because it's cheaper, and well, why would you look at NVDIMM or non-volatile? Basically, because commodity DRAM is, if I'm answering your question correctly, is volatile and doesn't offer you any persistence.
Yeah, they have LES, local energy storage, to guarantee in case the power lose, so they can save.
Okay,
the
that's what NBDIMM is. It's DRAM.
Not NVDM, not the DIMM backup with some capacity or like battery. It's in the whole server, not in some DRAM.
Okay, well that's an interesting solution. I'd need to look into that.
Several years ago, they announced the distributed battery. It's same as that.
Okay. Okay. If it's not NVDIMM that you're talking about, but it's got all the value of persistent memory at lower cost, I'd be interested to understand that. Yes.
So you mentioned the ecosystem that needs to follow along to do the adoption for 3D
Yeah.
Crosspoint. So what actually? So I'm representing the enterprise side, and so what are sort of the platforms by which these alignments can happen? Because it seems to me, even in this conference, there's been a disconnect between what the application world describes on how fast things need to get, and sort of like this gap in between to link the operating systems providers and other application environments to really benefit from this or harness.
Okay. I think the question is, how can we identify the gaps needed to develop the ecosystem? I think more from a hardware perspective, because there seems to be a big disconnect between the hardware world and potentially the software ecosystem. So if we're clear about which ecosystem we're talking about, we talk about here mainly about the hardware ecosystem. We have made progress. So where are the areas that you need alignment to get to scale? So in the hardware world, we still pay due recognition, and there's still a lot of work done with standards organizations like JEDEC. There's still a major enabler in platform enabler in the hardware world that is involved in all things compute, based in Santa Clara. There are the sheer the market forces around DRAM alone can either be a positive or negative when it comes to developing more niche memory solutions, and that's not to be underestimated in terms of where major companies drive resource. That said, we've already seen via the development in the Linux and Windows driver that as major customers and major partners start to coalesce around the value here, the doors start to open. and allows sections of the hardware world to start to innovate and produce the solutions like NVDIMM, for example. So there's just some very, very big rocks that need to be pushed off the road to get to, and it's been a long time since there's been multiple commodity-type memory media in the market. We've got DRAM and NAND, but from a compute perspective, we only talk about DRAM. Now we talk about other things. And I'm using 3D Crosspoint because it's publicly known about, yeah.
I think a lot of the OS work that you're talking about is being driven by Ken's group at Intel and into the Linux kernel. There's tremendous stuff going on there, and then Microsoft has picked up a lot of that same group from Ken's group.
And that's still only the OS, yes?
Yeah.
Yeah.
But there's things like SVDK and a whole new model coming up with new semantics of accessing memory.
Yeah, so 445, okay, that will be the topic of my talk.
They can't hear you if you can.
So 445 this afternoon, that'll be the topic of my talk.
There we go.
Stay until the last talk of the
Thanks,
afternoon.
yeah.
So, sorry, are you from Intel?
I am, yeah, Ken Gibson from
Okay, so Ken from Intel. It must have been a planted question. Thank you.
Appreciate it.
Okay, I'm just about out of time, but okay, I'm getting 5 minutes. Excuse me. If there's any other questions? My friend here.
Does Micron have access to the Crosspoint DIMM interface and drivers that Intel has released in January?
Unfortunately, on 3D Crosspoint, I can't comment on that. It's still part of our joint development project. So, unfortunately, but I can't really go into much detail on 3D Crosspoint. Okay, any other questions? Don't want to end on a negative note. Any other questions, comments? Okay. Anyone not believe all this? Just out of interest? Okay, well, that's fine. Healthy skepticism is always a good thing. Okay, well, I'm going to wrap up now and say thank you very much. I appreciate your time.